Hey everyone, welcome back to another episode. In the last episode, we created a little, kind of, terrain generation thing, where, it creates some hills and mountains and that kind of stuff, but, there were some issues with it. We sorted them out, but there's still an issue that we need to fix, and we're gonna add water and a little bit of, object generation. But first of all, thank you for David Robertson for his support on Patreon. It helps a lot. If you want to donate, it's in the description. And also join on community Discord. Anyway, so first of all, what I'm going to do is just import a few models that I'm going to use. So I'm just going to call these models. Inside models, I'll make another folder called nature. And I'm just going to import my models that I have. I'm going to drag them in. And they're a bit of low poly assets, not the tile one, nor I want the shrub. And let's just remove tree 1 because it has some issues, and rock 2, we'll keep it simple. Cool, so now I've got a few of these, we're going to set up some materials. You can also just slap texture maps on these as well, it works the same way. Now let's just turn these into prefabs. So we're going to drag them in. Oh, that's on the game view. 1, 2, 3, 4, take all of these, reset transforms. So they've all got 0, 0. Just a tip, it's important to use vibrant colors in kind of a low poly game. It makes it look a bit more naturistic almost. Looks a bit more nice. Cool. So we're gonna create pretty much the way it's gonna work is if we click play. First of all, we need to fix a bug with it being dark. We'll recalculate the normals when the terrain is still underneath, so we need to fix that. And second of all, the way it's going to work is we're going to create a more detailed mesh on top of this one, whereas a list of vertices, which we can place the trees in for each one of these, and that will take place after each chunk is made. So let's do that. Now scripts, let's go into the terrain generation script, and then down at the bottom we're just going to change the recalculate normals. We're going to cut that out, and we're going to put that just before we set the mesh. So let's go back into our Unity, and as you can see now it's using the proper correct materials and the proper correct colors. Also, you might be getting this, that's just from the tiling. We can also change the tiling to match it. So I'm pretty sure if we set it to something more like 0.5 or 0.25, it should be fixed from that. 0.25 should be good, because then it's a good size. You can still see some creases, and that's just from separate terrains. It's quite hard to fix that without using, custom graphics renders and that kind of stuff. So, and then another thing I'm going to quickly do is in here, I'm just going to spread out the noise of this a little bit more, so then we can get, some more hills, so then it becomes more prominent when there's where water should be. So now if we click play, as you can see, it's a lot more spread out. We might even want to increase it again, and then also spread out this noise here. Then if we click play, as you can see, we've probably got a bit better of a terrain in my opinion. It's a bit more smooth, a bit more nice. We can also increase the amount that it changes it by 128, making it quite steep. Looking pretty good. Also, I'm just going to change the field of view of our camera to be the far place to be 10,000, because right now it is very short and it is annoying me. Alright, so we've had a little bit of a hiccup, but after we recalculate normals, don't worry about the hiccup, it doesn't affect you. After we recalculate normals, we're going to go up and we're going to start creating some trees. So in our chunk generation script, we're going to make a public game object array, and we're going to call them trees. Then in our terrain generation, when we're creating our vertices, what we can do is we can check if we want to spawn a tree, right? So we can go float does spawn, and let's set it equal to mathf.perlinnoise, and we're just going to input a few values here. We can go x plus transform dot position dot x plus chunk gen dot seed, and then let's also go by z plus transform dot position dot z plus chunk gen dot seed. And then if we want this to be true, then we can spawn some trees in. So let's go float what spawns and let's set it equal to mathf.perlinnoise, and let's also go just the same thing here. Just copy this, but instead of this, we're just going to multiply the chunkgen.seed by a number so that it's just the noise goes further away. If you think of it as being mapped as a texture. Awesome. So that's going to be further away now, and then so we can figure out what spawns. So we can go what spawns is equal to what spawns multiplied by the number of trees that we have. So we could go chunkgen.trees.length. Then we could go what spawns is equal to mathf.clamp, because we need to clamp the value between. Sorry, not clamp. Round to int. We need to round it. Round to int. Because we can go int. Actually, wait. We can keep this as a float. Actually, mathf.round to int, and we can put in the what spawns. Cool. So now we can instantiate the trees, or the chunkgen.trees of what spawns. Now this is a float, so we need to tell it's an integer because we've already rounded it to an int, and we're gonna instantiate it at the position, so we can instantiate it at the vertex, so x, so a new vector 3 at x, y, and z. Really basic like that. Well, actually, it's x multiplied by that, and it's z multiplied by that to get the true positions. And we can also give it the transform as what it should instantiate under. So if we go back to Unity now, of course, 44. Oh, we need to give it the quaternion dot identity instead, and then down here we could also turn this into a game object. Current is equal to instantiate it, and then we could go current dot transform dot parent is equal to transform. Awesome. Cool. Now let's give it a few trees. We'll give it 2 trees. Assign these in there, and now let's click play and see what happens. Awesome. So as you can see, they're all kind of spawning in this exact same spot, but they are spawning, and they are spawning there. Now I'll get to why they're doing this in a second, but the way we fix this is we need to add the positions onto them, right? So in the position that it spawns at, we could go that plus transform.position.x. For the sake of it, we'll add the y position as well, in case you have them in the sky. And let's add the z as well. Cool. Let's go back. Now, the reason why those trees were in the center is because their pivot points are in the center. So when you're actually modeling the tree, I've made a mistake here. You need to put the pivot points in the bottom, so down here on the object, rather than right smack in the center. Otherwise, they'll instantiate in the center rather than on the bottom. And as you can see, now we've got kind of a whole grid of this. Now, how do we get it so then the does spawn actually works, right? Because right now it's doing nothing. We can actually go we could go here if put the I++ above all of this. We could go if no, actually, sorry, you gotta put it below. My bad. We could go if does spawn is above. We could give this a tree threshold now, so we can make a public float tree threshold. And if it is above the tree threshold, then we will spawn them in. Not tree threshold, it's chunkgen.tree threshold. Cool, so now let's go out. It's set, at the moment, the tree threshold is set to 0, so they'll spawn as much as they want. Whereas if we set this to something like 0.9 and then click play, as you can see, very little will spawn. Very little indeed. So if we set something like 0.3, many will spawn. So it's just about finding that balance. You can also scale out the noise a bit if you want to be something different, you know. Now let's add some water. So what we're going to do for this, you could add the water and make a new game object and then code the water yourself, as in like code the sizing and all that kind of stuff. We're just going to add just some water and just some really basic water. So let's create, let's make a game object, 3D object, let's create a plane, we're going to call this water, drag it into the prefabs, we'll just give it a really basic material, nothing special, and let's set the material type as transparent, we'll give it a nice blue, no smooth, actually we'll go max smoothness, something like that. Cool, now we've got some water, you know, it's a bit transparent, all that kind of stuff. Now what we're going to do is turn off shadow casting, so that it can't cast shadows and kind of ruin it. Turn off the mesh collider, we'll give it no mesh collider, because maybe if you want to make it that you can swim, make it a little bit different. Awesome, so now as you can see we have water, we can kind of see through it, it's probably not obvious here, but if we were to do this, you can't see through it, but if we go here and turn down the transparency on this, we can see through it. Awesome. So now we've got water. Now what we've got to do is we've got to add the water in the very center of all our chunks, right? So we could go, in the start method, we could instantiate water. So let's go ahead and create a public game object. Let's call it water. And here we can instantiate the water. And now here we can, oh my god, I just absolutely butchered that statement. Instantiate the water, and here we can give it a position to instantiate it at. So we can give it the center of all of these. Now how do we figure that out, right? So if we know each chunk is 128 by 128, based on this math that we've done down here, then we can pretty much just go a new vector 3 at 128, I'll put these in brackets, 128 multiplied by the chunks dot x divided by 2, and then for the y we're going to set that to 0, or actually we need to give it a water level, right? So we could go public float water level. Now you can also make this random by just going water level is equal to mathf.perl_noise between well, we need to give it a few vectors, right? So we need to give it the seed, let's multiply this by 0.2, oh actually it doesn't matter, but at the end we need to multiply this by something like 50, and then instantiate water, we can set the y level to water level, which is now random, and let's also give, I just completely ruined that, lol. Inside the vector 3, sorry, divided by 2, give it the water level, and then give it the 128 multiplied by chunks of z, and then we can divide this by 2. Cool, now that's where we've summoned it in, or spawned it, so now we can give it the quaternion.identity. Awesome. Vector 2 does not contain a definition for z. That's vector, that's y. Awesome. I have been given it one argument, have I? Awesome. So now if we give it the water, and then we click play, the water level should randomize. As you can see, it's at 23. Now, if we go to the water, as you can see, it's right smack in the center here, right? Like it's still small. We need to scale it all the way to be that size. So if we scale it to be that size, as you can see, it's something like 40. Why is it 40? Is that 41? Or is that's too much? It's 38. At 9. we could just scale it up by like 128 by 128, or something like that. So we can go here, something big, preferably. We can set game object current, and let's set equal to instantiate. We can go current dot transform dot local scale is equal to a new vector 3, and we can give it a new vector 3 for this. So we can go so like 128, 128. Let's go back to Unity. Obviously, this is not at all practical because you might have a huge terrain and then you'll have to make it even bigger. But if for huge terrains, I'd recommend making small pockets of water instead. And let's click play. And as you can see, we have now water in our terrain. Awesome. Cool. And this can be expanded to pretty much everything. Now with these trees, just real quick, we might want to make it so then the trees don't spawn underwater. So in that case, we can go also, if it's above the tree threshold and the chunk gen dot water level, so actually the y is more than the chunk dot gen dot water level, plus something like 5 will give it like a buffer zone. So now if we go back to Unity and click play again, then as you can see, there's a little bit of a buffer zone before the trees start back up. And these are very small, like you probably want to increase the size of them. Something that you can do is actually, these prefabs kind of suck. So what you could do is go trees, create empty, tree, or just tree, drag in the tree model in the nature. And then as you can see, the pivot point's down at the bottom and the tree's up top. Pretty goddamn simple. Here we go. Models, materials, bark, leaves. We'll just give it the one tree, make it really simple for them, for the thing to use for now. Awesome. So now if we click play, the trees are now, actually well done. And if we want to also scale this up a bit, which we probably do because it's quite small, inside here we could give it something like, a 5 by 5 by 5 increase, and we could also set this to something like 3.5 as the top, so then it's still kind of in the center. Awesome, there we go. And as you can see, it's a little bit all uniform, right? So we might want to add a little bit of offset of that. So instead we can add offset, so public, sorry, just a float called offset is equal to mathf.perl noise. You could do this forever, just adding perl and noise to everything essentially, and then we can give it the x plus transform.position.x plus chunkgen.seed. But what we could do is go like x multiplied by x, so it's x squared. The possibilities are really endless in what you can do with this kind of stuff. It's actually really cool that you're able to do all this as easy as you can. And then here we can just add the offset, plus offset if you want, and then you can in the chunk generation you can just go like public float tree offset scale, so then like, or tree uniformity or tree randomness actually makes more sense. So we can multiply by the tree randomness or the chunk gen.tree randomness. And here we've added the offset. Awesome. Let's click play again after maybe setting the randomness to something like 0.4. We'll see how much that changes them by. That really doesn't change them by much. As you can see, it's a little bit off though. So like 4. See how much 4 changes it. Oh. Yeah, as you can see, they're all like slightly off. You can, again, you can really change this by anything. You might even want to just, instead of that, I'm trying to keep everything fairly like Perl and noise based, but if you don't want to do that, you can also just you know, random.range between something like 1 and 3 or 1 and 2 or even 0 and 1. How about that? Now if we click play, it will be all random. Oh, apparently not. But like if you don't want it to be constant all over the whole thing, what you can do is instead of in the does spawn, you can always just add more to the does spawn. So we can go does spawn, you know, by the way, that can be 10, and we just divide by 10 afterwards. Offset is equal to offset divided by 10. But does spawn maybe minus equals to more spread out noise, so we can go you know, that multiplied by 0.1. This all isn't necessary, by the way. Like, I've already provided you with the base stuff to be able to do this. Yeah, as you can see, now it's only spawning them in a certain area, and all that kind of stuff. But yeah, and the same applies to underwater objects as well. You just set the same thing that I did with making sure that the and Y level is more than water level. It's pretty simple. Anyone can figure this kind of stuff out. It's very basic. Anyway, guys, hope you enjoyed. If you did, don't forget to subscribe. Check out my Patreon and Discord. It really helps. Also, if you guys have any questions, just ask them on the Discord. I'm sure someone on there will help. Most likely me. Anyway, I hope you guys had an amazing day, and thank you for watching.